These are the problems from Chapter 4, sample problems from Chapter 4. Question 1 is about the definition of work. Remember what we said, work involves two things. It involves a force and it involves a displacement, but the two must be parallel. So our definition of work is force times parallel distance, or the force and the distance must be parallel. So the correct answer here is B. This question number 2, talks about a student moving an object not parallel to the lamp, and the force is applied parallel to the lamp. So if we apply what we did in the last question, work is force times parallel distance to the lamp. Not if we say given, what are we given? We are given here the distance, and it is 8 meters. And we are given the force, and that force is 300 newtons, and we are trying to find the work. And so the work is given by this relationship. All we need to do is put in the value. So this is 300 newtons multiplied by 8 meters, and what we'll get is 2400 newton meter. So the correct answer is C. This question relates to work and potential energy. So it says, which path would accomplish more work? Work relates to the transfer of energy. The energy here is the change in potential energy. Potential energy depends only on height. And since it depends only on height, it is independent of the path taken. Independent of path taken. And since it's independent of path taken, the correct answer here would be D. This question talks about two students running up the flight of stairs at different times. Note, work doesn't involve time. Work is force parallel times distance. Our distance here is the height. The force in this case is the weight. Weight is always m times g, so this is equal to mgh. And since the height is the same for both students, it implies they will do the same work. And so the correct answer here is C. Question number 5 is very similar. We know we are given the mass of the student, which is 75 kilograms. We are given the height, which is 50 meters. And we know, of course, that G is 9.8 meters per second squared. Therefore, the gravitational potential energy, which leads to the change here, is simply equal to mgh. And so if we put in the values, we'll have 75 times 50 times 9.8. I've left out the units, and the answer here will end up to be 3.68 times 10 to the power 4, and the units are joules. And so the correct answer is C. Question number 6. Remember what we said, kinetic energy is the energy of motion. Kinetic energy is energy of motion. Symbolically, kinetic energy is equal to 1/2 mv squared. This means that the object is moving because it has velocity or speed. And therefore, the answer to question number 6 is simply B, because the object is moving. Question number 7. Now, question number 7, let's write what we are given. So we are given, again, the mass, and the mass is 1,000 kilograms. Now, that's good. We are given the speed, but the speed is written as 30 kilometers per hour. We can't use that. We need to use always meters, seconds, kilogram, and so on in the standard SI unit. So we need to change this from meters, kilometers per hour to meters per second. If you look up in your book, the conversion factor will look like this. It will say 1 kilometer per hour is equal to 0.278 meters per second. So the first thing we need to do is to make a conversion, and here it is. So it will be 30 kilometers per hour. This is equal to 30 kilometers per hour times a conversion factor. Our conversion factor will be 0.278 meters per second and 1 kilometer per hour, arranged in such a way that we can cancel the kilometer per hour. And if we do that, our answer will end up to be 8.34 meters per second. Now we can calculate the kinetic energy that he wants. So the kinetic energy, therefore, will simply equal to 1/2 the mass times the velocity squared. Note, this is the energy it has to overcome to bring it to a stop. And so this is 1/2, and the mass was 1,000. And here we had 8.34. I've left out the units and square this. If you do this, you'll find that the answer ends up to be 34,778 joules, or 35,000 joules. And so the correct answer there is D. This problem looks at dropping a book from a height and want to find the speed at the bottom. So what we are doing really is we are converting all the potential energy at the top into the kinetic energy at the bottom. What are we given? Well, we are given the mass of the book, which is 10 kilograms. We are given the height, which is 2 meters, and we know that G is 9.8 meters per second squared. But in this relationship, note the mass is irrelevant because the mass cancels out. And so what we have is that the velocity is equal to 2gh and square root if you rearrange that equation above. Put in the values, we'll have 2 times, again I'll leave out the units for brevity's sake, 9.8 times 2. And if you do the math, this comes out to be approximately 6.3 meters per second. And so the answer to question number 12 is D. The next question, it says, it's talking about the definition of mechanical energy. Remember what we said? The total energy of any isolated system cannot change. It always remains constant. So the answer here is C. The last question, again, talks about the law of the conservation of energy. And we say the total energy is constant. Energy cannot be destroyed or created. So again, the correct answer is C. And that's it for Chapter 4.